So, today I'm going to talk to you about random data generation with ScalaCheck. It's not actually a talk on ScalaCheck, so apologies if you have been a little bit misleading. What I'm going to do today is actually I'm going to present a slightly different way of using ScalaCheck. So usually, you know, when we test things in Scala, we have two approaches. The pretty simple approach of just using predefined test data and then use that test data to run our tests. And we have the amazing ScalaCheck library that will do all the magic for us. So what ScalaCheck will do is that it will automatically generate some test data starting from the most generic case scenario, and it will shrink it until it will find the data that breaks our test. And these two approaches are really common. I believe that everyone is aware of them. So just review really quickly what they are. Again, static fixtures is basically you predefine all your test data. And that is OK, but that means that your test data will be completely biased. So how many times you guys, it happened to me that a test failed, it happened to me that a bug was found because I wasn't testing that specific edge case scenario. And then you have ScalaCheck. So really quickly, ScalaCheck is a really powerful library that allows you to define certain properties over your test data. And what it will do is that it will generate data and it will find an example that breaks your test. So it's really, really cool. But there is a problem. The problem is that one approach is completely biased and the other one doesn't work well with side effects. So for example, I'm currently working with a retailer, with a startup that works in the retailer sector that is called PayTouch. And we have this service. It's really simple, nothing fancy. We have a service that we call core that has a database that is dedicated to the service. And then we have a REST API. And obviously, there are some integration with other parts of the system and other third parties. And we really, really wanted to test this really well because it is the core of our system and we are a startup, so we do need to be reliable. So what we said is, OK, we are going to do BDD, where basically each test will define the behavior of our service. And that worked well, but at the same time, we had, because the retail business is so complex, we couldn't really think of all the possible edge case scenarios, so we wanted to do something a little bit more than testing with predefined test data. So we thought, OK, we're going to use ScalaCheck. But then we realized that we had so many tests that ScalaCheck wasn't really the case. The reason why ScalaCheck wasn't useful for us is because we are using Postgres, so we were testing against the real database. That means that if we have 600 tests, ScalaCheck will run each test 100 times. 600 multiplied by 100, that's 60,000 tests. And the database wasn't really happy about it. Also, the tests we're taking, right now, the tests take around 4 minutes. So we could have improved our infrastructure to have a bigger database to handle the load. But again, we are a startup, we're not Netflix, so we don't have a lot of money to spend on infrastructure. So we are in a situation where basically we have the normal approach that is a little bit simplistic. We want to make sure that we represent all our edge case scenarios, but at the same time, we cannot really use ScalaCheck. So what do you do? And that is the reason why we thought maybe there is a way to run the tests once, but using random data. So this way, all we have to do is to measure the side effects that our API generates. That means that every time we make a call, we will check that the data in the database is is what we expect, then we make the call to the third parties, and so on and so forth. So that's the reason why we spent quite some time. We played a little bit around with things, and we created this library that is called Random Data Generator. And so far it's working really well for us. We are going to see later on how we actually implemented it. It's surprisingly simple. But let me show you really quickly what this API, this library looks like. Again, really simple. So suppose that you have a case class example with a text and an n. All you have to do is just say, give me a random instance of example. And we will reuse ScalaCheck to do all the work for us. So how do we use this in a test? Again, nothing fancy. So this is a normal test that probably you guys have seen around. So we have a test that will assert that we create a user. So we have a random user, and no matter what the user actually is, we want to check that when we call the API post users, then the API will respond with 201 created, and we will have to check that the user is actually in the database. What you would normally do is that you will predefine what a user is. What we have done here is we say, actually, just use a random user. So that's pretty simple to use. You don't have, usually in ScalaCheck, you have to rethink the way you are testing things. Here, you really don't. You just have to change that line. But obviously, this means that our tests are not deterministic anymore, right? Because every time we run our tests, it will be run towards different test data. So obviously, once we find a session, a set of data that breaks our test, we want to have the opportunity to replicate that specific session. So what we have done is that every time you run your tests, we will select a seed, and that seed will be used to generate all the random test data. So if you find a bug, obviously you want to fix it. So you have the opportunity of fixing the seed, rerun the test again. This time the test will be deterministic, and you will have an opportunity of fixing whatever bug it's in your code. So we start using this approach, and it started working really well for us. In particular, we found out that we didn't worry too much about all the edge case scenarios that we didn't cover, because sooner or later this library was highlighting issues in our code. And yet we had the opportunity of making this test deterministic when there were issues. And amazingly, we found so many bugs all over the place. So that's amazing, right? Because we found the bugs, it wasn't the client. So that's actually pretty cool. So we kept using it again, and again. And we also found out that the code was actually a lot easier to maintain. The reason why is that is because the test doesn't really care what a user is, because it's going to be the library that will generate an instance of a user. So if I suddenly change the user and I had a field in my case class, the test will be exactly the same. So that was another nice advantage as well. Also, our tests become a lot more readable. So when you have tests that highlight a specific issue in the data, like for example, this test is a test that will make sure that if you try to create a user that has an age that is below 18 or 21, since we are in the States, it will reject the request, and it will make sure that we didn't actually create the user in the database. So in this code, it's really clear that the important piece of information of our case class is actually the age. We don't care about anything else. The important bit is the age. But how did we implement this library? This library is mainly composed by two elements. The first element is obviously ScalaCheck, right? We don't want to reinvent the wheel. We have this amazing library that will generate the data, right? And it will generate the data in a way that the edge case scenarios are actually more common than the regular case scenarios. So we will select the seed, and then give an arbitrary, we will get the generator, and we will get an instance of t. Okay, a little bit slower. Arbitrary. Arbitrary is the class of ScalaCheck that will include the generator in your scope. That's all it does, nothing else. The generator, gen, is the heart of ScalaCheck. So that's the real magic. Is going to be the class that defines how you generate a specific type. And then obviously, we can sample it by giving it a seed. So we have two entry points, right? So we have the seed, and we said that we are going to select one for you. And we have the arbitrary. But where is the arbitrary coming from? And that's the amazing thing about ScalaCheck Shapeless. I strongly suggest you to use it, even when you use ScalaCheck, or in general when you need to generate things automatically, because basically what you usually have to do with ScalaCheck is that you manually have to define all your generators, and that's boring. We don't want to do boring. So ScalaCheck Shapeless actually will automatically create all the generators for you. And the way it works is that it will be able to infer automatically the arbitrary as long as T is an algebraic data type. That for humans, that means it's either a case class or a CL trait. So it's a really, really nice library, again, that I suggest everyone to check out. But obviously, the compiler is doing a lot of things that we don't want to do. So obviously, the compilation time will be affected by that. But hopefully, Miles will fix that as well. So things are going to be amazing in the future. Just let him work. So what happens if ScalaCheck Shapeless is not really able to infer stuff, infer our type? Obviously, we still have the old way, the boring way. So we can still define arbitraries manually. So for example, if we use Java util currency, that is a common way of defining currencies, all we have to do is to define an arbitrary and say that an arbitrary is a generator of one of the available currencies. So it's not too bad. So once you start using this library, you will find yourself arguing about your tests. So what happens is that you will either think that your code is wrong, or the data that you generated is nonsense. So when you use this library and ScalaCheck in general, you do need to make sure that the data that is going to generate makes sense. So what happens if in your application you have particular requirements? For example, when you generate a string with ScalaCheck, this thing over there is a string. Surprisingly, but it is a valid string. So maybe, in particular, if you have a database, that is not a valid string for your context. So what you want to do is that you want to tell ScalaCheck what is a valid string in your context. So what you can do is to define a new arbitrary that is just saying that a string for you is just a list of letters. But what if you are happy with the way a type is generally defined, but you're not happy of how that type is defined within a case class? You can still do it. So for example, we have this case class that is a person with a name and an age, and we just define that an arbitrary is is composed by a name that is one of Daniela John Martin, and an age that is an int between 0 and 100. So there is a little bit of configuration still to do. 90% or probably 95% of the time, ScalaCheck will be enough. But obviously, you do need to be aware of making sure that your data is reasonable. So actually, ScalaCheck is not a library for random data generation. And this is really weird because my talk is actually called exactly that way. And the library is actually called random data generation. So ScalaCheck is not a library for generating random data. The reason why is that because that ScalaCheck is biased towards edge cases. So if you use this library to populate a database or do some statistics analysis or whatever, you will find that most of the data that is generated covers the edge case scenarios rather than the more standard ones. So if you are looking for a tool that will generate random data to populate a database, this is probably not the tool for you. But if you're looking for a tool that is generating data in a way that it will make sure to test the edge case scenarios first, then this is the tool for you. So to summarize, most of the time, ScalaCheck will be enough for you. And I do strongly suggest to use ScalaCheck if you can. If you cannot really use ScalaCheck because you have a lot of side effects and that is stopping you from doing that, then this library is a good compromise between completely using predefined test data. Also be aware of what it means to have, what is the meaning behind your data. Because otherwise you will find a lot of tests that are failing simply because the generated data doesn't really make sense. If you use this library, you will find out that every once in a while, tests will fail randomly. And this is the nature of the library. So obviously, do not ignore those test failures. That's the whole point of the library. Just take the seed number, reproduce the session, and try to understand why the test failed. And again, please be aware that all the data that is generated will look weird. So don't use this library to generate data to maybe store in a database or stuff like that. Please just use it for test purposes. And then last one is just a great sentence from a guy. You might probably have heard of it, Ayestra. That just reminds us why testing is so damn difficult. And he's basically saying that with testing, you cannot really demonstrate that something works. You can only demonstrate that something doesn't work. And that is the reason why testing is sometimes so damn difficult. So that is everything for me. If you guys are interested, have a look at the library. The link is there. And that's about it. Thank you very much, guys. Are there any questions? Do we have time for questions, yeah?
Question is, you have your REST service and you run test once and successful. You run test twice and successful. So at what point you make decision that actually the software is ready for production?
Sorry, can you repeat the question?
You do multiple tests run and all of them is successful.
Yes.
So does it mean that this software is actually ready for production or it doesn't have bug? doesn't have bugs or?
Well, that's the whole point of testing. You cannot prove that something is correct. You can only highlight presence of bugs. So obviously, the more you run the test, this is not ScalaCheck, right? So if you want to have a higher confidence that the test will work, then ScalaCheck is the way. But obviously, the more you use this library, the more issues it will highlight. So no, if the test passed doesn't mean that the code is perfect. Just means that he didn't find any problems with the test data that he generated.
How do you deal with options? Because you probably want to test none and some, and then if you have two options, you have a problem.
There is actually a nice high-order function in ScalaCheck that will deal with that. So once you generate, for example, a generator of a string, ScalaCheck has a high-order function that will automatically convert that generator of a string into a generator of an option of a string. So that's easy enough to do. Did I answer your question?
My question was more like you have a user and it has an optional attribute.
Okay.
So each time you probably want to test that user with none and also that user with some. So you need to test at least twice.
In that case, I will probably do 2 tests because using random test data means that you can really predict that that field will be some or it will be none. In that case, I will write 2 tests saying this field needs to be none because, this field needs to be some because. In that case, I think it could be summarized to this case where a specific field within the data has a specific meaning. So in that case, yeah, I wouldn't leave it to chance because again, random data means there can be some, it could be none. You don't know. So I will keep it separate. Please.
This is sort of related, but say you have just a string. If you don't control specifically for the empty string, sometimes you'll get empty string and sometimes you won't. Do you need to write 2 versions of every test to test for, say, empty string cases and other like 0 for integers and other special cases?
Well, if you have a specific requirement that you should never have an empty string, you should have a test that says, okay, if I send an empty string, my behavior will be the one that I expect. If your context of the system will guarantee that you will never have an empty string, what you can do is that you can change the generator of a string to not generate empty strings. Okay, cool. Okay, thank you guys very much. Cheers.